Section 5.6 deals with inverse relations and functions. This should be a fairly easy section for us to get through. As far as inverse functions are concerned, the key is to first we need to switch the x and y coordinates. And then from there, you're just solving. Okay? So if they ask you to find the inverse of a function, you go ahead, switch x and y, and then solve for y again. There's a couple different ways it could be notated. They could flat out tell you to find the inverse, or the more common one is they have f to the -1 of x. So there's a couple ways we can do this. First off would be a table. Table is probably just like the easiest one there is. When they give you a table, like they do in example 1, literally all you are doing is just switching the x and y values. So for my original, my top value, or my top row, was all the x values, bottom was all the y's. To find the inverse right there, so that f -1 means inverse, you are literally just taking the two rows and switching them. So my y row now goes up top. It'll give me -6, -2, 2, and 6. And then my bottom row is going to be -3, -1, 1, 3. Just literally we flip the two rows. The second question, this is a common one you're going to run into, is the inverse for problem number 1 a function? So going all the way back to Algebra 1, an inverse is only going to be a function if every x coordinate has only one y coordinate. So there's a couple ways you can go about doing this. The most common one would probably be a mapping diagram where you list out all the x values that are given to you. So for this one, we got 6, 2, -2, -6. And then we just draw arrows out going to the y values. So these are my x's, these are my y's. You don't write the number twice. So if the number shows up multiple times in the table, you just do it once for each column. So if it shows up multiple times for the x, you just write it once. If it shows up multiple times for the y, you just write it once. So there's my x's, my y's over here. I got 3, 1, -1, -3, and the -6 is paired up with the -3. The -2 goes to the -1. 2 goes to 1. 6 goes to 3. Okay, so when I look at this, each of my x values only have one arrow coming out. So if they only have one arrow coming out, that means each x only has one y. So that since that is the case, we can say that yes, it is a function. If on any of these x values we had two arrows coming out, that'd be right away, it's not a function. Okay, so at any point on a mapping diagram, if you have two arrows leaving the x's, we know it is not a function. So that's the first way, finding an inverse table-wise. The second way would be graphically. So for graphically, we're just going to go through and we're going to find good points. Okay, so we're going to find good points on the graph, x and y, and we're just going to flip them. It's symmetrical across the line y equals x, which, I mean, is important, but it really doesn't mean that much to us in this class right here. So example 2, we have a graph. With this graph, I'm going to go ahead and find the good points on it. So where we cross, so I got one there. That point is -4, -4. I'm going to go ahead and list them over here. So I got a point at -4, -4. My next good point is going to be -2, -3. I got a point at 0, -2. Got a point at 2, -1. And then we got a point at 4, 0. Okay, so that's my original graph in the blue. To find the inverse, what you need to do, just like we did in the table, is just take your values and switch them. So -4, -4, nothing's going to go on there. I'm still going to have a dot here at -4, -4. The next point, though, when I switch them, it's going to be different. So you got -3, -2. Tells me to left 3, down 2. I get -2, 0, so left 2. I get -1, 2, so we're going left 1, up 2. And then we got 0, 4. So I'm just going up 4. Okay. From there, just connect the dots. And there's our inverse. Okay. So for a table, switch x and y. Graph, find the good points, switch x and y, and then graph the new line. The third one, and probably the most important, for being honest here, is algebraically. So for each of these, they want you to find the inverse for them. They want proper notation and everything. So our first step here is I'm going to rewrite it where it's y equals 5x minus 2. Okay, just remember f of x, pretty much the same thing as y. It's our output. From there, find the inverse. You need to switch x and y. And then lastly, you need to solve for y. So solving for y, I add 2 to both sides. And then lastly, you get y by itself. You divide everything by 5. So y equals x plus 2 over 5. Now, they want us to use proper notation. Proper notation for an inverse would be that -1 power. So since I had f of x, I'm going to say f to the -1 of x is equal to x plus 2 over 5. Okay, so that would be the inverse for f. G, we're going to go through the same steps. Instead of wasting a step for like writing the y, I'm just going to flip it right away. So I get x equals y squared minus 1. Go ahead and add 1 to each side. X plus 1 equals y squared. Go ahead, square root each side. And I'm left with the square root of x plus 1 equals y. Again, we need to use the proper notation here. And actually, what we got to watch out for, though, since we have took a square root, we need to make sure the plus or minus here. Okay. But again, proper notation, instead of y, I'm going to say g to the -1 of x equals plus or minus the square root x plus 1. Okay, last one, I got h, same deal, switch x and y, so x equals 1/2 y cubed minus 2. And then we need to get h by itself, so add 2 to both sides. Got to get rid of the half by multiplying by 2. When I multiply by 2, it's going to turn into 2x plus 4. Just remember, everything has to get multiplied by that. Equals y cubed. And then you take the cube root of each side. So we get the cube root of 2x plus 4 equals y. Proper notation again. Since we're dealing with h, it should be h to the -1 of x equals cube root 2x plus 4. And that's section 5-6.